Hello, everyone, and welcome to how Coinbase handles incident management by leveraging AWS. My name is Lalita Maraj, and I'm an infrastructure engineer at Coinbase. I work out of the New York office. And today, I'll be presenting with my friend and coworker, Amy Lee.
Hi, everyone. My name is Amy Lee, and I'm a site reliability engineer at Coinbase, and I work out of the SF headquarters. So let's get into it. For those of you who are unfamiliar with our company, Coinbase is the easiest place to buy, sell, and trade cryptocurrencies. With our main flagship product, you can manage your portfolio. It's where you can buy and sell popular listed digital assets such as Bitcoin and Ethereum. Since your portfolio contains digital cash, it is extremely important to us to be available and secure 24/7 and ensure that each customer has the correct balance in their portfolio at all times. In a similar vein, we have Coinbase Pro. Coinbase Pro is the most trusted platform for trading cryptocurrency. We promise to ensure that the real-time order books, trading tools, and trade history are up and running. Our customers should always be able to make a simple order process so that they can start trading from day one. So once again, it's really important to us to have our trading engines up and running 24/7. I've stated that our products must be the easiest to use and the most trusted, but how do you actually maintain that customer trust? To provide the best service for our customers, we must be secure and reliable. But, it's not always realistic to expect 100% uptime. Sometimes your service catches fire and things break. It is at this moment the ability to handle incidents well can generate a lot of value and long-term success for your company. At this critical point, I'd like to present two different outcomes for you. Imagine a scenario where an incident is not handled well and it's very chaotic. I'm sure many of us in this room have been in this similar situation before. Nobody knows what actions their coworkers are taking. Nobody is communicating properly and stating what they've done and what needs to be done. Suddenly, the incident escalates and senior management is involved. These business leaders are demanding ETAs every 5 minutes, and no one is consistently updating them on what is going on, because everybody would rather focus their energy on solving the technical issue at hand. Engineers who could have lent a hand in debugging or resolving the issue are not being used effectively. And ultimately, there is an erosion of trust between your customers and your company. Now let me present to you an alternative reality where incidents are managed well. At Coinbase, incidents don't feel chaotic or stressful, even given the high stakes and the money on the line, because we have built tools and set processes in place in order to, first of all, limit the disruption caused by the incident, resolve our services and get them running very quickly, and then finally uphold our promise to be secure and reliable by having long-term improvements. Now I'll hand it over to Lalita, who's going to kick us off with how this incident management process begins.
Thank you, Amy. To have an incident management process, we of course need an incident to happen. An incident can happen in a variety of ways. In one use case, you may have a situation where users are unable to access your website. They potentially are experiencing 500 errors. In another instance, you may have performance degradation. And in another situation, you may experience a security vulnerability. Once that incident starts, your team will then kick off an incident management process. Once that process begins, teams can start assembling. These teams are known as the incident team. These teams will be used to focus on investigating the incident or communicating internally or outwards about the problem at hand. Hopefully, after some thorough investigation, your teams can then move on to resolving the incident. And last but not least, we hope that our teams can finish off the incident by completing the postmortem process. As you can see, there are a number of steps involved with the incident management process at Coinbase. We care about these steps And as a result, we focused our energy in building tools and automations to help our engineers move through this process. Today, we will be walking you through how we've done a few things to help them do so. First, we've built out toolings to help enable communication. Secondly, the infrastructure team has built tooling and automation to enable fast and secure deployments to infrastructure and software. And lastly, we've automated and guided our engineers through this entire process. To better understand how this incident management process works, let's walk through a fictitious demo. Although this is a hypothetical incident, we will be walking you through all of the steps that our engineers will engage in if they were involved in an actual incident. Let's begin. Meet Julia. Julia is a software developer on our portfolio development team. She's been at the company for a few months now, and she's shipped both front-end and back-end features. We consider her a full-stack engineer. Now that Julia has a few features under her belt and is pretty familiar with her system, it's time for her to go on call. And Julia's on call this week. Let the fun begin. So picture this, it's 3 a.m. Julia's fast asleep, and the last thing she's thinking about is work. But that's soon about to change. She's woken up by an alarm on her phone. Julia jumps out of bed, takes that annoying alarm off, and then looks at her phone. She realizes an alarm from one of the services her team manages is going off. Seems to be that an elevated rate of 500 errors are happening. Julia then rushes out of bed, scrambles to find her laptop, and navigates to her team's website. When she logs on, she sees that she herself cannot visit the website. And that's when Julia realizes it's time to start an incident. To start an incident, Julia opens up Slack. Here at Coinbase, we leverage Slack to do a lot of communication within the company. The infrastructure team then thought it was reasonable to build an incident bot integrated into Slack. Now it's time for Julia to start that incident. She's going to engage with the incident bot by issuing the incident command. Our incident bot then asks her a few questions. We're going to start off and determine what she would like to do. Julia could either start a new incident, manage incidents that she's opened, or list all current active incidents at Coinbase. Given the alarms, she's going to start a new incident. After that, Incident Bot asks Julia for a few questions. She needs to answer things such as the title of the incident, a brief summary, customer impact, and severity level. Keep in mind, we're very early on in this incident. Julia may not understand every single detail, but this is a good starting point, and everyone understands that these details may change as we learn more about the incident. Once Julia does that, she has a few other questions to answer. Let's say this incident, we realize, involved other teams. Potentially, this incident involves a security vulnerability. Here on this screen, Julia has the opportunity to escalate this incident to other teams, so she could escalate it to the security team. But for now, this incident seems to be within the scope of her team, so she will just simply move on to creating and starting off this incident. Once she does that, a few things get created. An incident doc is generated. This incident doc is the place where important incident details are memorialized. During our postmortem process, this incident doc is finalized. Secondly, a video chat room is created for all members of the incident team to convene in. Lastly, a ticket is generated. This ticket is used to track the state of the incident as well as key incident metrics that we as an organization care about. Once Julia creates that incident, those details that she entered in initially are posted to our general incident channel. This is a channel that different members of our organization are members of. They use this channel to keep track of all new incidents that have been created. If I were keeping track of this channel, I'd see that a new incident has been reported, and all of the details that Julia had initially entered are posted here. Why is this useful? If I read this and I realize this is an incident I should probably be a part of, I can join in on that incident by clicking that incident channel link below. That incident channel link will direct me to an incident channel that has been created specifically for this incident. This channel will become the main point of communication for this incident. As you can see, we have convenient links here to the artifacts that were created for our incident, the incident doc, the video chat room, as well as the ticket that was created for this incident. Below, Julia starts off the conversation by posting a status update. She lets everyone know that she is the incident commander and that she's seeing an elevated rate of 500 errors. Julia has mentioned that she is the incident commander. Here at Coinbase, we value the role of our incident commanders. As an incident commander, you're not responsible for resolving the incident. Instead, you're responsible for driving teams through the incident process. Julia, instead of focusing on resolving the incident, will instead be focused on creating the incident team to get all of the folks that have the appropriate context on the problem on the incident, driving communication. In the last slide, Julia did a great job of first starting off the conversation by letting people know where we stand on the incident. As Julia's doing this, she's keeping us up to date on all of the incident steps, moving us through the process. Hopefully, she can finish off all the steps and then complete the incident process. Julia became the incident commander because she created the incident. However, if Julia felt that she didn't have the right context, she could always delegate this role to someone else, perhaps her manager, or maybe someone on a team that's responsible for the failing service. However, Julia feels equipped to handle this incident. But the key thing here is that anyone can open an incident at Coinbase. This lowers the barrier of entry for starting on resolving incidents. Now that Julia feels confident that she can move forward on this incident, she can go ahead and form an incident team. So as Julia is looking into this, she realizes customers are suffering right now. They're seeing 500 errors. So she decides to page the comms team. To do so, Julia again engages with our incident bot. On Slack, she issues the page command. That then calls up incident bot. An incident bot allows her to page a team and link that team to a specific incident. In this situation, she's paging the comms team and linking them to the incident that she had created. Once she does that, they're directed to the Slack channel where all of the conversation is being held. As we can see, John fortunately responds to her page and lets Julia know that he has updated the status page. Now that that's taken care of, Julia is ready to take a closer look at the incident. But she realizes she needs help. Julia reaches out to Alice and asks if she can help. Alice fortunately responds and offers to help by joining the video chat room. Now keep in mind, it's around 3-something in the morning. Julia and Alice aren't in the office, but the video chat room allows them to have real-time communication. These two now are ready to investigate the incident. To investigate the incident, Julia and Alice need to take a look at AWS. Julia is a member of our portfolio team. At Coinbase, like many of your companies, we have several different services. We would like to enable different teams to have access to the infrastructure that their services run on. However, we want to make sure we're doing so in a way where we don't give them too much access to services they don't need to touch. And additionally, we want to give them appropriate levels of access. To solve for this, we've done a few things. We've separated our services by creating several AWS accounts dedicated to different environments and different services. Additionally, instead of thinking about what exact permissions Julia needs, we take a step back and think, what does the portfolio team need access to? In that way, what we do is we say the portfolio team just needs access to the blue accounts, which are the portfolio-related accounts. This helps the infrastructure team a lot because instead of handcrafting each individual developer's permissions, we can just simply say, what does the portfolio team need access to? What does this look like when you log onto AWS? When any member of the portfolio team logs on, they're given options to log into one of the accounts they have access to. And in this case, they have access to the portfolio accounts. And in each of those accounts, they could either assume the read role or the portfolio ops role. Again, keep in mind, no one had to reach out to infra. They're able to move forward on this on their own. Julia and Alice want to take a look at some of the CloudWatch metrics, so what they're going to do is assume the read role. And for our read role, what we've done as an infrastructure team is assign exactly what permissions the read role should have. And in this case, we're delegating read permissions to some of our CloudWatch metrics. Again, we're able to enable these teams to get to the data that they need to without needing to involve another team, and in this case, infra. As Julia and Alice start to look into the problem, they realize they're starting to understand it better. They have several users hitting their website, and it has uncovered a problem. They need to increase the max number of connections their database can support. Now it's time to make some changes, and they're ready to resolve the incident. Julia, as our incident commander, is going to then post a status update to let everyone know they've uncovered the issue and a fix is in progress. If you're following along with this incident, you can now start to understand how this incident is unfolding. You're not in the dark. Now it's time for Alice to make these changes. We as an infrastructure team would like to give our developers access to make changes to their infrastructure. But at the same time, we'd like to make sure that we're always secure and we have our development teams following best practices. To accomplish this, we've decided to invest in codifying our AWS infrastructure. By codifying our AWS infrastructure, we've been able to achieve a few benefits. Our changes are auditable. Picture this, you're in an incident and you realize something's not quite right with your infrastructure. You can quickly look at the code repository hosting your AWS changes to understand, has a change been made recently? If you make a change and realize it's not appropriate, you can easily reverse that change by reverting your code. And lastly, the infrastructure team, as I mentioned, cares about certain validations and best practices. We can enforce that here by not being physically present in the process, but instead by adding checks in the code repository to ensure that no code is applied or merged without passing these validation checks. Now let's get back to Alice. Alice can make these AWS changes by codifying these changes locally. She can then push up these changes to our source control. And from there, a bot that we've built can look at her changes and then give her an output of the expected changes she can anticipate once applied in her account. Once Alice secures the necessary approvals, she can go ahead and merge in those changes. Another bot then can go ahead and apply those AWS changes. Why is this relevant to an incident? During an incident, everyone here gets stressed. And that can cause for potentially making silly mistakes. And so let's say if you're logging in, doing this manually on the AWS console, you might make a silly mistake. But however, by codifying this, we guarantee that we always need someone to approve our changes. Secondly, no manual intervention is necessary here. We have bots that can go ahead and make only the intended changes. And last but not least, infrastructure was not the bottleneck here. We were able to give Alice the changes, the ability to make the changes she needed. Great. Now Alice has pushed through those changes, and Julia notes that this seems to be improving the problem. We see that we have a decreased number of 500s. However, on their video chat, Alice realized that yesterday someone had pushed out a change where we had a query that was pushed out. Alice notes that that query could have been improved, and so Alice starts working on a software fix to optimize that query. Now as Alice, you can all imagine you have a software fix and you just want to get it out. You want to serve your users and you want to be able to ship that software fix fast. At Coinbase, we rely on several different AWS services to host our software. We use EC2 instances, AWS Lambdas, step functions, and S3 buckets. Again, we as an infrastructure team and our security teams would like to enforce certain security best practices, but we can't always be involved with every single deploy. We would slow down the organization significantly. As a result, we've built deployers that use things such as CloudFormation and SAM templates that are able to automate the deployment process while we are able to configure the best practices that we want our developers to follow. With these deployers, Alice is able to move forward and deploy her change quickly. Once she does that, Julia then starts to monitor the CloudWatch metrics again, and she notices that things are starting to resolve. So now, Julia is ready to mark this incident as resolved. She thanks everyone, and now she's ready to go back to bed, finally. And before we can consider this incident completely resolved, we need to go ahead and complete the postmortem process. And I'm going to hand it back to Amy, who will walk you through what that looks like at Coinbase.
Thanks, Lolita. So just because the incident is resolved doesn't mean we can just go back to our regular schedule. I would argue the most important work comes after an incident, which is why streamlining any part of the incident management process enables Coinbase engineers to move fast and learn quickly from failure. The reason why I strongly believe that the most important work comes after an incident is because the postmortem process prevents engineers from responding to an incident poorly. Unless we have a formal process in place, we will never learn from our mistakes. The same issue may occur repeatedly. You could be applying patches to the same incident over and over again, but that's just going to cause long-term tech debt. So we want to mitigate this long-term tech debt by prioritizing work to fix systemic issues. Even when we conduct a retrospective and prioritize work to mitigate further bugs, it's a terrible and unproductive situation when an individual or a team is blamed for causing an incident. These are all things that we want to avoid with the ideal incident management process. Now I'm going to go through what an ideal incident response process looks like. First, we decide if an incident even warrants a postmortem. At Coinbase, we have developed a severity matrix to decide when to move forward with the postmortem process. We want to get the most out of a postmortem, so it doesn't make sense to run a retrospective meeting and follow through with the entire process unless we're going to actually uncover valuable learning opportunities for the company. So at Coinbase, everything above SEV3 is considered a major incident, and it is mandatory to continue with the postmortem process. I'm going to just very quickly give some examples on each severity level and what they constitute. Sub-5 incidents refers to incidents that have just cosmetic issues or bugs, and it doesn't impact a customer's ability to use the product. Similarly, Sub-4 incidents also don't impact a customer's ability to use the product, and there's usually an intuitive workaround, such as refreshing the page. Above that, that's when we start impacting customers. Sub-3s are major issues that requires immediate action from the service owners to fix the incident. So for example, there's a bug in the buy-sell flow, and it requires somebody on that team to fix that issue. Above that are SEV2 issues, and these are major issues that are impacting a certain percentage of Coinbase customers. For example, there could be really degraded performance issues on the site. Finally, SEV1 incidents warrants public notification and liaison with our executive teams. So in this case, if the entire website is down and customers are unable to access the site completely and use our features, that would be a SEV1 incident. So in Julia's case, this is a SEV1 incident, and the next step she has to take is schedule a postmortem meeting. So when you schedule this postmortem meeting, how do you actually make it successful? I believe there are two key components in running a successful postmortem. First of all, it has to be blameless. At Coinbase, we believe it's unproductive to point fingers. No one is coming into work and intentionally trying to do a bad job. During an incident, everyone has good intentions to resolve the incident, and everyone is doing the best that they can given the limited information that they have. If the culture of finger pointing and shaming individuals persists at a company, this could lead to employees being afraid to point out issues because they don't want to feel or be punished. Instead of having a negative attitude and viewing an incident as a failure, view it as an amazing opportunity that has finally discovered this hidden issue, and now you can make your system or service more resilient and more reliable. You can't control an individual's actions 100%, but you can set up systems and processes to guide them in the right direction. So now we have an opportunity to collaborate and finally focus on what caused the incident. Another part of a successful postmortem is having an extensive root cause analysis. At Coinbase, we practice the 5 whys because we want to go beyond human error as an explanation. We want to dig deep to find system or process problems that we can fix in order to mitigate further bugs. Another crucial and mandatory step of the postmortem meeting is to record and complete the incident metrics. As a heavily regulated company, Coinbase must record metrics for compliance reasons. When we collect metrics over time, we can easily identify outliers and capture long-term trends. Below, here are some examples of metrics that we can collect from an incident. Time to detect refers to the amount of time it takes us to notice the incident. So let's say the incident in our hypothetical situation started at midnight, and then Julia finally discovered it at 3 a.m. So in this case, 3 hours was the time to detect. Time to engage refers to the amount of time it takes for the appropriate engineer to be looped into the incident. So in our case, Alice was looped in at 3:18, so it took 18 minutes for her to engage. Time to fix literally refers to the amount of time required to resolve the incident. And in our example, since the entire incident was resolved at 3:45 a.m., so 3:45 minus 18, that's 27 minutes for time to fix. Auto detection refers to a metric where we answer yes, no, and it refers to whether the incident was actually automatically detected through monitoring. This is an important metric because if we don't have good monitoring in place, then we're blind to potential issues. That's an entire talk on its own. Finally, we have stakeholder communication. At Coinbase, we always ask 2 important questions. Did we notify the right stakeholders, and did we notify them in a timely manner? This metric should always trend towards yes, and if it's not, then that's a really significant outlier to investigate. After the retrospective, the incident commander is responsible for communicating learnings outwards to organization via retrospective email. Why is this important? The retrospective email is important for visibility and for communicating learnings and improvements to the rest of the organization. Sending the email to the company allows leadership and other engineering managers to see what happened. After running a postmortem meeting and going through all that effort of discovering what you've learned, it's very valuable to share out that knowledge. Finally, adding a list of improvements that you and your team will take is important. At Coinbase, if a retrospective email lacks sufficient action items or sufficient details, then other engineering managers or even directors will follow up and ask for more details in the email thread. Finally, our last step is to run an engineering postmortem review meeting every 2 weeks, and this meeting discusses all the Sev1 incidents that has happened with leadership. This is how we reinforce a collaborative postmortem culture by involving senior management in the review process. As you can see, these are a lot of steps to follow, and each step takes a lot of work. So introducing a postmortem culture into your organization is definitely easier said than done. It requires a lot of effort, continuous cultivation, and reinforcement. How did we go from all of these bad characteristics of an unmanaged incident response process to all of the good attributes of an ideal incident response process? Well, at Coinbase, in less than a week, we built a very basic service called ReminderBot with the goal of reminding people through Slack and email to follow through with the postmortem process. Let's see how all the tasks that ReminderBot needs to do is assembled. You can see that there are 2 Lambda functions. In our first Lambda function, it's responsible for using Amazon's simple email service to send out that engineering postmortem email to all engineers. It's also responsible for using Slack to send out daily reminders to the incident commander of any task that they have to do, or to nudge them through the process. In this Lambda on the bottom, that's responsible for sending out the auto-generated retrospective email template to the incident commander. Our service pulls all necessary information from Jira, and the reason why we have 2 Lambda functions is because sending out that retro email is on a separate schedule. So we use AWS Lambda because it definitely checks a lot of the requirements that we have. We can trigger events through a schedule, either through a cron expression or a rate expression, so now we're able to send out those daily Slack reminders. It has built-in fault tolerance since AWS Lambda maintains compute capacity across multiple availability zones in each region, so now we can sleep at night and we don't have to worry that our code will fail because of individual machine outages or failures. We don't need to provision or manage our servers because AWS takes care of that. And best of all, it is pay-per-use, so it's very cost-effective. So how do we actually define our serverless application? We use SAM, and SAM makes it really easy to build templates. Adding another Lambda is as easy as adding another resource into your SAM template. So here we have the reminder resource and the retro email resource. They have very similar properties, but the key difference is that they run on different schedules. The reminder service has a cron expression as its schedule, and essentially what this is saying is to run at 5 p.m. UTC or 9 a.m. Pacific time every single day from Monday to Friday. The retro email service, however, is on a separate schedule, and it's set to a rate of 5 minutes. So incident commanders should receive the auto-generated retrospective email template within 5 minutes of completing incident metrics and updating the Jira issue. SES is really great for controlling access to who can see the email and from what email domain. We have verified email domains in order to prevent spoofing. So in this policy, it allows our Lambda in order to send emails through SES, and secure transport is also enabled through TLS. Now let's see how ReminderBot guides Julia through the rest of the postmortem process after resolving the hypothetical incident. Julia and her engineers, after fixing everything, are eager to go back to shipping code because we gotta hit those quarterly OKRs. Soon she forgets about scheduling the postmortem meeting. Fortunately, ReminderBot sends her a Slack message and tells her to schedule it. She schedules the meeting the next day and gathers all the appropriate engineers involved in the incident. During the postmortem meeting, Julia and other engineers spend most of their time on the postmortem document. And this was created earlier at the beginning of the incident. They spent a lot of time going over the root cause analysis, what went well, what didn't go well, and what kind of improvements that they have to make. She fills out some of the incident metrics, but soon they run out of time. Fortunately, ReminderBot will collect all of the outstanding reminders for Julia. ReminderBot does this by, first of all, gathering all the incidents that has been created in the past 30 days, because we've noticed that engineers typically go from creating an incident to resolving it to completing the postmortem within 30 days. Each metric is its own reminder, and each nudge to move the incident ticket status is also its own reminder. So here we consolidate it all into one string and add it into our incident reminders map. We iterate through that map and send a Slack message to the incident commander regarding the outstanding tasks that they need to complete for the incident. Here, Julia will receive this Slack reminder, and she has to fill out some of these metrics and also update the JIRA status to postmortem complete once she fills it all out. Once she does that, she initially dreads writing that retrospective email because historically it has been very painful and takes a non-trivial amount of time in order to compile all of that information. At Coinbase, engineers used to have to sift through old documentation, find an example of a retrospective email, take out all of those irrelevant metrics, plug in all of their metrics, and then finally they can get on to writing the summary and explanation, etc. Fortunately, ReminderBot is here to create that retrospective email template for her. What we do is we gather the incident data and its metrics and put it into a Go template. From that, we can have the subject and the body, and we can finally send that to the incident commander. Now, Julia will receive this email template, and it's a lot less friction and toil for her to just complete the TLDR, the summary, the explanation of the root cause, and a list of improvements that they have to make. Standardizing the email improves clarity because now readers know what to expect in this email template and where certain information are located. For example, if I was interested in auto detection, then I know I can go straight to the bottom of the email and it'll be right under metrics. After Julia sends out that email, she still has to attend that engineering postmortem review meeting. But thankfully, ReminderBot can send out a reminder email for the organization, letting everyone know when and where that meeting takes place. So in order to assemble this email, it takes in the meeting time, the meeting rooms, a list of SAV1 incidents that need to be reviewed with senior management, and also a list of incidents that are in violation. The reason why we also collect these incidents that are in violation is because we want to hold incident commanders accountable. These are SAV1 incidents, so it's really important to follow through with the entire process. After we inject all of this data into another Go template, we send that out to the organization. So now, Julia has received this email, and she sees that her incident is up for review. And she also knows that she has to go to Ethereum in the SF office. So these are the 5 steps that Coinbase follows during the incident response process. ReminderBot has helped Julia through 4 of these steps and continues to help engineers at Coinbase to this day to complete that process. As a result, these parts of the process feel a lot more effortless and streamlined. Now I'll hand it back to Lolita to wrap up.
Thank you, Amy. As we conclude, we hope to reiterate a few pieces from our incident management process that we hope you can take back to your organizations. Coinbase has invested a lot of time in standardizing communication during incidents. During an incident, we don't want our incident commanders to think about how do I communicate? Who should I loop in? What mechanisms should I use to blast out this message? Instead, we wanted them to focus on the important things at hand, gathering the right teams, and eventually moving through to resolving and completing the postmortem process. In our example, we use Slack to integrate our incident bot. But I encourage you all to think about what communication tools are important at your company and how can you integrate something such as an incident bot into that tool. Secondly, the video chat room that is created is a great way to allow engineers that aren't in the same room to have real-time communication. In our example, Julia and Alice weren't at the office. They were at their respective homes. But the video chat room that was already created for them gave them an easy way for them to communicate. Thirdly, the ticket that is associated with this incident is a great way to know where should I go if I want metrics. It's our one-stop shop for metrics related to this incident. And lastly, the incident doc that is eventually finalized during the postmortem process will be the one-stop place for all relevant incident details. Here, we have a standard way on how we communicate during incidents. Secondly, as you grow your teams, if you're an infrastructure team, I'd like you to think about how can you build tools and automation to remove yourself from the process of deploying changes. You want to be able to enable your developers so that they could make decisions fast and eventually resolve problems. By giving them transparency and the ability to make control changes, you're not only helping your teams, but you're helping your customers. And lastly, you're helping yourselves so you're not always paged during an incident. And lastly, this is a pretty long list of steps. Hopefully, your engineers aren't engaged in incidents every day. And as a result, these steps won't be at their fingertips. During an incident, the last thing you want to ask someone to do is to dig up documentation on all of the relevant steps. Instead, you want to guide them through these steps that you believe are important. Give them a little nudge when they've fallen behind and tell them exactly what they need to do next. Together, that will incentivize engineers to move through the incident management process and get to the final stage, the postmortem process, where you can take away key learnings and improvements that you can make to your general system. Amy and I would like to thank you all for attending our talk today. We hope that you could take some of this back to your organizations and enhance the way that you all handle incidents. With that said, we'd love for you to follow us on Twitter, and we invite any questions that you may have. Thank you.